Hello and welcome to my channel, and this will be another filament review, but a little bit different. What I have here is the lightweight PLA, and this package is sent to me by eSun in exchange for a review. Now this material is designed for RC planes or drone parts or similar, because the density of this material may be even 0.54 grams per cubic centimeters. Just for comparison, regular PLA has a density of approximately 1.2 grams per cubic centimeters. Water has a density of 1. And if you're not familiar with density, I recently built this website where you can find thousands of materials there, and also you can find the conversion where you can convert the density unit to any combination of the mass and volume. Now back to this material. This PLA has some additives which in function of the temperature may create some foam, and the volume will expand, and this means in the function of temperature we can have a different density. There is a very useful table on the eSun website where we can see in function of temperature what extrusion rate we have to use, because if it will expand then we have to reduce the extrusion rate to even 45 degrees Celsius, for example, because after this creating of the foam, the volume to the nozzle will be the same as a regular PLA. If we look at this table, which shows us the temperature between 200 and 280 degrees Celsius, and for me two lines are most important here. You can see the extrusion rate on 200-210 degrees Celsius is 100, and in this case the density will be as a regular PLA of 1.2 grams per cubic centimeters. But above this, those foams start to be created, and we can reduce the extrusion rate, and with this the density will be lowered also. And from this table I can see the lowest density I can get if I print it between 260 to 270 degrees Celsius. In this case the extrusion rate has to be only 45%. And the density will be approximately 0.54 grams per cubic centimeters. And I believe that this information is also very important, that the speed must be approximately 40 millimeters per second, because it needs time for this foam to be created. Don't forget that with those budget 3D printers like Ender 3, Ender 5, you cannot print these high temperatures, because their hot end has a structure where the bottom of Teflon tube goes down touching the nozzle, and the Teflon, if it is constantly above 240 degrees Celsius, may produce some toxic fumes. In this case I would recommend you to replace it with some all-metal hot end. I could recommend, for example, a micro Swiss. It is very popular, it can be replaced in 10 minutes. Only a hot end, you don't need a direct drive. You still have the limit of the firmware probably, which sets the temperature up to 260 degrees Celsius. But in this video I show you how can you modify the firmware and go even to the higher temperatures. Another thing which we have to keep in mind, that in this case now the retraction will not work. Similar like with the TPU, we can expect a lot of stringing. So we have to keep in mind this when we create a design for our product. It is best if we print something, I don't know, in vase mode or something like that. The stringing can be removed, but it is better if our design is prepared for this, so we don't have this problem. Okay, let's now see what's in the box, and let's analyze the spool. This is the spool. It is nice vacuum packaging. There is a silica gel inside, and we have a sticker about the basic informations. We can find it here too. It says ePLA-LW, lightweight, 1 kilogram of spool, printing temperature between 190 and 270 degrees Celsius. Now keep in mind that if you print it below 220 degrees Celsius, it will act just like a regular PLA, so it's better in that case to use regular PLA instead of this lightweight. Temperature of the bed is recommended between 45 and 60 degrees Celsius. So probably I will just use the regular 60 degrees Celsius as usually do with the PLA. And this is my first test object, and here I painted these seams to be on this side. And then in the filament settings I set the temperature to 265 degrees Celsius and extrusion multiplier to 0.45, that's 45%. The fan speed only to 20%, and I disabled the auto cooling because I don't want to have any higher value for this. And then the speed, as suggested, everything on 40 millimeters per second, even the first layer speed, and retraction to 0. And I used the brim on this object because it has very small contact surface. There's the brim, super fast because even the first layer starts with 40 millimeters per second. And as you can see here, it would be very big stringing if it would be different object. Since the retraction with this filament don't work so good, the seams are very visible. That's why it is important to plan the position of the seams if possible. You can do it in the PrusaSlicer and also in Cura. And it's almost finished. It has constant quality from the beginning until the top, even if the layer printing time is quite short and the cooling fan is set only to 20%. The string. Let's check the layer adhesion. Okay, that's fine. Wow, it's really light. I will remove the brim and I will measure the weight. And just for comparison, this part is printed from eSun PLA+. What I can tell you for the feeling, it is super light compared to this PLA+. The feeling, it is like cardboard. Very nice matte finishing, and already as I mentioned here, the seams are very visible. And well, on this object I don't have that problem, but I'm sure that if there were some separated areas, the stringing would be very visible. Quick check for the wall thickness, it should be 0.8 millimeters. This one is 0.83. And this one 0.82. So quite equal. I'm starting with the PLA+. 2.788 grams. And now the same volume. This is lightweight PLA. 1.1 gram. But how strong is this part? Just first quick test when I press it with my finger with the same force. I can feel, of course, that the PLA Plus is stronger than this lightweight PLA. But let's measure it somehow. 40 millimeter distance. What I will do, I will place this small crane scale here in the middle and I will pull it. And these are not my standard test specimens. I'm not even sure what will happen. Maybe it will bend, or maybe the layer will be detached, or maybe they will compress here. But let's find out together. That was strong. And now lightweight PLA. And this is how they broke. They actually bend a little bit until they are separate on one of the layers. Well, definitely PLA Plus is much stronger, and if you check my PLA test, definitely for all types of the PLA, this PLA Plus has the strongest layer adhesion, so it's not comparable, but just for the reference I compared with these two. On product website they mentioned that this material has good layer adhesion. And these are my test specimens for layer adhesion test. The smallest cross-section area is 4 by 4 millimeters. And these are now my standard test objects for layer adhesion, so the results are comparable with the other materials, for example with PLA+. And as I expected, a lot of stringing can be visible here, but this is something we can not avoid. But it is very easy to clean it at the end. First I remove the brim and now these strings. And again just a small weight comparison before the pulling test. 2.502 grams the PLA and light PLA 0.911. Well, the layer adhesion actually is noticeably weaker than regular PLA or PLA+. And these are the results compared to the other eSun PLA types. Another claim from product website is that it is resistant to explosion. Well, I don't have a dynamite at home, but I can test it with some impact test. If we are talking with explosions, this material is very flammable because there is a lot of air between the material. This is the brim of one of object, and look at this. Just pay attention to this. And now let's see the impact test. And I also printed some other test specimens. These are for horizontal, tensile strength, temperature test and impact test. This is my standard impact tester with half kilogram hammer, and I will see if this material is brittle similar like a regular PLA, then the difference between zero position and swinging after the breaking the test specimen will be approximately 20-30 millimeters. Let's find out. This is the position of the hammer after breaking a lightweight PLA, and this is the zero position. And as you can see, the difference between two positions is 13 millimeters. And here are the results compared to the other eSun PLA. And you can see, well, this lightweight PLA is quite brittle material. The broken cross-section area. And now the tensile strength test, and these test specimens are printed in horizontal position. And again, these are my standard test specimens. Smallest cross-section area is 4 by 4 millimeters. So these results are also comparable with other experiments. Well, again, from the first feeling, definitely this is not strong as a regular PLA, the tensile strength, but actually I can see the air, the foam in this cross-section. So this is a normal thing that this has to be weaker because the real cross-section is not 4 by 4 millimeter, but it is reduced because there are air gaps between material. Now one more thing I want to try, and only now it came up to my mind, and that is to print it on 240 degrees Celsius, because I know that a lot of my viewers have NS3 or similar type of the 3D printer. And I mean, I have an NS3 V2, but it is fully upgraded all metal hot and direct drive. Instead, I would like to print it on Voxelab Aquila, which is perfect NS3 V2 clone. And it doesn't have any upgrades, and it still has that Bowden type of the extruder. And I will not print all test specimens, only the most important, I think, from this aspect. And it is at first some kind of pipe, because it has the properties which are most commonly used in RC modeling, which is some kind of shell structure. These are my print settings in Cura, and don't forget some of them are only visible if you enable the expert mode. The temperature is 240 degrees Celsius, Flow rate is 55%. According to the table, printing speed everywhere 40 mm per second, even the first layer, fan to 20%. And I also disabled the retraction. And I enabled the brim because it has very small contact surface. Quick check the layer adhesion until it's hot, and okay, no problem with adhesion, so definitely just a regular PLA. I didn't use any adhesion material on the surface. Okay, let's remove the brim. And wow, I think this is better quality than on my Prusa. I mean, probably I will have the stringing here too, I can see thanks to this line. But the seams looks much better. Even inside they are hardly visible. And now let's see the weight. .315. And now this one, which is printed at 240 degrees Celsius on PrusaSlicer. This one printed on 240 degrees Celsius also broke between two layers. And now let's see side by side, compare the quality. So here you can compare the seams on printed on Prusa on 265 degrees Celsius, and this one was on PrusaSlicer. Just small seam here, and inside also much nicer printing on 240 degrees Celsius compared to this one on 265. I'm not sure, is it Prusa or the big temperature difference. Do you know the story of Icarus? Well, he is the guy who flew too high and the sun melted the wax on his wings and he fell down. Well, with our RC planes we don't have that danger, because we know that on higher altitude the temperature decreases. Bigger danger is that maybe we will forget our plane model in a car on hot summer day and they will deform. Maybe not actually, but we will see. Maybe this PLA goes through the annealing process on these higher temperatures. Well, let's find out actually. This is why I need this experiment. This is lightweight PLA, and I will place here just a regular PLA, which I know it will deform on approximately 50 degrees Celsius. I want to record the temperature at the first deformation. Soft, just like a regular PLA. So as you can see, don't leave your RC plane inside the car on hot summer day. And don't fly too high close to the sun, like Icarus. And now I'm ready to fly. This is now powder coated sheet because it has big surface and it will be easier to remove it after the printing. Very interesting that here when the nozzle moved from this part to the tail, we can see a lot of stringing, but I will clean it up and put some here M3 bolt and see how it flies. Of course I have to wait this textured surface to cool down. It will be easy to remove the plane. Wow, it is so light. 4.2 grams, ridiculous. Let's make an A-frame from A4 sheet and measure that. And here it is, not too elegant, but let's measure it. 5.107 grams, so it's heavier almost by 1 gram compared to the lightweight PLA. And now the conclusions. Well, actually I'm really impressed with the 3D printed objects from lightweight PLA with their weight. Of course the strength is weaker compared to the regular PLA, but this is the price you have to pay if you want super lightweight objects. And you don't have to go on so high temperatures like I did. Printing on 240 degrees Celsius you can still have half of the density compared to the regular PLA. And the object is even nicer. Of course, in settings, don't forget you have to reduce the flow rate according to that table. Printing speed is 40 millimeters per second constantly, even on the first layer. You have to reduce the fan speed to 10 or 20% and also disable the retraction. I don't predict too long life to this small plane because the thickness of the wings is only 2 layers. But I'm really impressed of this weight, so let's see if it will fly. Quite good. One more time. Maybe in opposite direction. Good, only I need more space. And it's still in one piece. Thank you for watching and happy printing!